Hi everyone, I am Navyasree A J from Siddhartha Central School studying in class 10H. Today we are going to discuss about the 8th chapter of mathematics, Introduction to Trigonometry. And today we will be learning the most important topic in this chapter, trigonometric identities. Before going to our topic, let us have a quick recap on what is trigonometry. Trigonometry is the study of relationship between the three angles and three sides of a triangle. As you know, it's only applicable for right angle triangles. The word trigonometry derives from Greek, that is, tri means three, gun means side, and meter means measurement. Together it is trigonometry. Earlier, the astronomers used the aspect of trigonometry to measure the distance of stars and planets from the Earth. And even now, many advanced methods in engineering and physical science is based on the aspects in trigonometry. Later in this chapter, we learn about the trigonometric ratios, or the ratio of the three sides of a right angle triangle with respect to its acute angles, or the angles less than 90 degrees. We learn 6 trigonometric ratios such as sine, cos, tan, cosec, sec and co. For angle A, sine A is equal to the side opposite to angle A by hypotenuse. Cos A is equal to the side adjacent to angle A by hypotenuse. Tan A is equal to the side opposite to angle A by the side adjacent to angle A. Cosec A is equal to hypotenuse by the side opposite to angle A. Sec A is equal to hypotenuse by the side adjacent to angle A. Chord A is equal to the side adjacent to angle A by the side opposite to angle A. Now, let us move to our topic, trigonometric identity. Do you know when an equation is called an identity? An equation is called an identity when it is true for all the values for the variables involved in it. Let us take a very familiar example to make this point more clear. A plus b into a minus b is equal to a square minus b square. This is an algebraic identity. Now, why this equation is called an identity? This is because whatever values we give to the variables a and b, we get same values both the left hand side and the right hand side. That is why this equation is called an identity. As here it is the case of variables, this is called algebraic identity. Now, what is a trigonometric identity? Trigonometric identity involves trigonometric ratios in it, such as sec square a, tan square a, etc. It is an equation including trigonometric ratios which is true for all values of the angles involved in it. Now here it is the case of angles. As it contains trigonometric ratios, it is called trigonometric identity. Now in this section, we will prove three important trigonometric identity and will derive other equations from these three identities. For that, let us consider a triangle ABC, where angle B is equal to 90 degree. AB is its altitude, BC is its base, and AZ is its hypotenuse. So, in triangle ABC, we can say that AB square plus BC square is equal to AC square. That is, altitude square plus base square is equal to hypotenuse square. This is based on the Pythagoras theorem we have learned in our previous classes. So to prove the first identity, let us divide each of these terms by AC square so that the equation changes to AB square by AC square plus BC square by AC square is equal to AC square by AC square. Now if we take square common for both numerator and denominator, the equation again changes to AB by AC the whole square plus BC by AC the whole square is equal to AC by AC the whole square. Now here we consider the trigonometric ratios of angle A. Now for angle A, AB by AC is equal to the side adjacent to angle A by hypotenuse. And you know adjacent by hypotenuse means cos A. So AB by AC the whole square changes to cos A the whole square. Now BC by AC the whole square. For angle A, BC by AC means the side opposite to angle A by hypotenuse. And you know opposite by hypotenuse is equal to sine A. So BC by AC the whole square changes to sine A the whole square. AC by AC the whole square, we have same value in both the numerator and denominator. So AC by AC the whole square changes to 1 square or 1. Now rearranging the equation, we get cos A the whole square is equal to cos square A, sine A the whole square is equal to sine square A, and 1 square is 1. So here is our first trigonometric identity, cos square A plus sine square A is equal to 1. Now let us derive 4 more equations from this identity by arranging the terms from left hand side to the right hand side. First, let us move the cos square A to the right hand side. So the equation changes to sin square A is equal to 1 minus cos square A. Plus cos square A, as it goes to the right hand side, changes its sign to negative. So it becomes minus cos square A. Now let us move the square part in sin square A to the right hand side. So that it becomes sin A is equal to root of 1 minus cos square A. When square is moved to the other side, it changes to root of. Now let us move sin square A from the left hand side to the right hand side. So the equation again changes to cos square A is equal to 1 minus sin square A. Plus sin square A, as it is moved to the other side, it becomes minus sin square A. Now again, if we move the square from cos square A, it becomes cos A is equal to root of 1 minus sin square A. Now here are the four equations from the first identity. And the key point with these set of identities is that it is true for all values of A such that 0 degree less than or equal to A less than or equal to 90 degree. That is, the value of A should be either greater than or equal to 0 degree, or it should be less than or equal to 90 degree. Now, the second identity. For that, again we have the same triangle ABC where angle B is equal to 90 degree. And we have AB square plus BC square is equal to AC square. Now, to prove the second identity, let us divide each of these terms by AB square, so that the equation changes to AB square by AB square plus BC square by AB square is equal to AC square by AB square. Now, taking square common for both numerator and denominator, we get AB by AB the whole square plus BC by AB the whole square is equal to AC by AB the whole square. AB by AB the whole square. Here we have same value both in numerator and the denominator. So it changes to 1 square or 1. Now for angle A, here again we are considering the trigonometric ratios for angle A. For angle A, BC by AB means the side opposite to angle A by the side adjacent to it. And you know, opposite side by adjacent side is equal to tan A. So BC by AB the whole square changes to tan A the whole square. Now for angle A, AC by AB means hypotenuse by the side adjacent to it. And you know, hypotenuse by adjacent side is equal to sec A. So that AC by AB the whole square changes to sec A the whole square. Now again, if we are rearranging this equation, we will get 1 plus tan A the whole square changes to tan square A, and sec A the whole square changes to sec square A. So here is the second important identity. 1 plus tan square A is equal to sec square A. Now from this, we can derive other four equations by rearranging the terms from the left hand side to the right hand side. First, let us move the square part from sec square A to the other side, and it changes to sec A is equal to 1 plus root of 1 plus tan square A. Once the square is moved to the other side, it becomes root of 1 plus tan square A. Now again, let us move the tan square A to the other side. So the equation again changes to sec square A minus tan square A is equal to 1. It was plus tan square A before we moved it to the other side. So when it is moved to the other side, it becomes minus tan square A. Now again we are moving plus 1 to the other side. So the equation again changes to tan square A is equal to sec square A minus 1. Plus 1 when it is moved to the other side changes to minus 1. Now from tan square A, we are moving the square part to the other side. So the equation changes to tan A is equal to root of sec square A minus 1. Now, the point we should consider here is that this equation is true for all values of A such that 0 degree less than or equal to A less than 90 degree. If the value of A is equal to 90 degree, these set of equations are not true for it. Now, the third trigonometric identity. Again, we have the same triangle ABC where B is equal to 90 degree, such that AB square plus BC square is equal to AC square. Now for the third trigonometric identity, let us divide each of these terms by BC square, and thus it becomes AB square by BC square plus BC square by BC square is equal to AC square by BC square. Now taking square for common for both numerator and denominator, we get AB by BC the whole square plus BC by BC the whole square is equal to AC by BC the whole square. Now again we consider the ratios for angle A. For angle A, AB by BC means the side adjacent to angle A by the side opposite to angle A. And you know, adjacent by opposite means cot A. So AB by BC the whole square changes to cot A the whole square. Now BC by BC the whole square. We have same values both in numerator and denominator, so it changes to 1 square over 1. Now for angle A, AC by BC means hypotenuse by the opposite side of angle A. And you know hypotenuse by opposite means cosec A. So that AC by BC the whole square changes to cosec A the whole square. Now rearranging this equation we get cot A the whole square changes to cot square A. 1 square is 1. Cosec A the whole square changes to cosec square A. So here is our third trigonometric identity. Cot square A plus 1 is equal to cosec square A. Now again we are able to derive 4 more equations from this identity by rearranging the terms. First, let us move the squared part from the cosec square A to the other side so that the equation changes to cosec A is equal to root of cot square A plus 1. Now again if we change plus cot square A to the other side, it becomes minus cot square A and changes to cosec square A minus cot square A is equal to 1. Now again if we move plus 1 to the right hand side, it becomes minus 1 and the equation changes to cot square A is equal to cosec square A minus 1. Now again if we move the square part from cot square A to the other side, the equation again changes to cot A is equal to root of cosec square A minus 1. So here are the 4 set of equations from the third trigonometric identity. The key point with these set of identities is that this is true for all values of A such that 0 degree less than A less than or equal to 90 degree. That is, the value of A should be greater than 0 degree or it should be less than 90 degree or it should be equal to 90 degree. What happens if the value of A is 0 degree? This equation is not applicable when the value of A is equal to 0 degree. Now we know the 15 trigonometric identities. And using these identities, we are able to express a trigonometric ratio in terms of other trigonometric ratio. And if any one of the value of any one of the trigonometric ratio is known to us, we are able to find the value of other trigonometric ratios. Let us take an example for this. Suppose we know that tan A is equal to 1 by root 3. So from here we can say that cot A is equal to root 3 because cot A is the reciprocal of tan A. That is, if tan A is 1 by root 3, we can say that the value of cot A is the reciprocal of 1 by root 3. Therefore, the value of cot A here is root 3. And now from this, let us try to find out the value of sec A. For that, we should consider the trigonometric identity where we have sec A. That is the second set of identities. Here we have both sec A and tan A. And as the value of tan A is already known to us, it is easy to find out the value of sec A from this. From this, let us take the second equation, which is sec A is equal to root of 1 plus tan square A. So it becomes sec A is equal to root of 1 plus 1 by root 3 the whole square because tan A is 1 by root 3. So tan A the whole square becomes 1 by root 3 the whole square. Root of 1 plus 1 by root 3 the whole square is equal to root of 1 plus 1 by 3, which is equal to root of 4 by 3, that is equal to 2 by root 3. Now we got the value of sec A. And from this we can say that cos A is equal to root 3 by 2 because cos A is the reciprocal of sec A. And if sec A is 2 by root 3, then cos A is the reciprocal of 2 by root 3 or it is equal to root 3 by 2. Now from this, let us find out the value of sin A. For that, we need the first set of equation because it includes both sin A and cos A, and we now know the value of cos A. So it's easy to find out the value of sin A with these set of equations. From this, let us take the second equation, that is sin A is equal to root of 1 minus cos square A. That is sin A is equal to root of 1 minus root 3 by 2 the whole square, which is equal to root of 1 plus 3 by 4, and that is equal to root of 1 by 4, which is equal to 1 by 2. And here we got the value of sin A. And from this we can find the value of cosec A because cosec A is the reciprocal of sin A. And if sin A is 1 by 2, then the value of cosec A is the reciprocal of 1 by 2. Therefore, the value of cosec A here is 2. Now we saw an example where we can find the value of other trigonometric ratios if any one of the value is known to us. Let us see a different example. The question is, express the ratios cos A, tan A and sec A in terms of sin A. That is, here we have to express cos A, tan A and sec A in terms of sin A. First, cos A. We know that cos square A is equal to 1 minus sin square A. And from this we can say that cos A is equal to root of 1 minus sin square A. We have just moved the square part in the cos square A to the right hand side. So it becomes cos A is equal to root of 1 minus sin square A. So here we have done the first part, that is we have expressed cos A in terms of sin A. Let us mark this equation as equation number 1. Now the next part is tan A. We know that tan A is equal to sin A by cos A. But here we have cos A in the right hand side. So instead of cos A, we can also write root of 1 minus sin square A. We have proved it above that cos A is also equal to root of 1 minus sin square A. So instead of cos A, we can write root of 1 minus sin square A. So that tan A is equal to sin A by root of 1 minus sin square A. Now the next part is sec A. We know that sec A is the reciprocal of cos A. That is sec A is equal to 1 by cos A. But here again we have cos A in the right hand side. So instead of cos A, we are again writing it as root of 1 minus sin square A, as it is proved above. So here we expressed cos A, tan A and sec A in terms of sin A with the help of the trigonometric identities. So in this section we have proved 3 important trigonometric identities and we have derived the other identities from these 3 identities. And this is very easy as we don't have to by heart these equations. We just have to understand how the 3 important identities came, and from that we are able to derive the other equations. So hope this part is clear to you. Thank you.